Hello friends, welcome back. Hearty welcome to you. Let's look at this problem related to complex numbers asked in 2013. Let complex numbers alpha and 1 by alpha conjugate lies on circles x minus x dot whole square plus y minus y dot whole square equal to r square and x minus x dot whole square plus y minus y dot whole square equal to 4r square respectively. If z dot equal to x dot plus iy dot satisfies the equation 2 into mod of z dot whole square equal to r square plus 2, then alpha modulus or modulus of alpha is equal to how much? We have couple of options. We have to choose the correct option. So let me read through this again. We have been given that there are two complex numbers. One is alpha, another is 1 by alpha conjugate. They are lying on two different circles. But you can see from the circle definition, they are concentric circles. Both are the circles which are having center at x naught comma y naught. So this is the center x naught comma y naught. Let's write it down. That is x naught comma y naught. Center is x naught comma y naught. That is the center of both the circles. We can see that it's like x minus h whole square plus y minus k whole square equal to r square. So h comma k is the same for both of them. That means these two circles are concentric circles. What else we know? We know that alpha lies on the first circle. The first circle is with of radius r. So first circle, on the first circle there is a complex number alpha. So let us say alpha equal to a plus ib. That means in Argand diagram it's given by point a comma b. So let us say that point is a comma b. Then 1 by alpha dash 1 by alpha conjugate. Let us see what is alpha conjugate. Alpha conjugate we know is a minus ib. What is 1 by alpha conjugate? That is 1 by a minus ib. Now this is nothing but equal to a plus ib divided by a plus ib you are multiplying with, so it will become a square plus b square. Or can I say the point on the diagram on the plane is a by a square plus b square comma b by a square plus b square. That is the point what we have for the second complex number. So let us say this is the point a by a square plus b square comma b divided by a square plus b square. This is the, so whatever we know just we have kept on the diagram, and they have given us another extra condition. What is that condition? 2 into z naught square equal to r square plus 2, and they said z naught is x naught plus iy naught. I'll write that z naught equal to x naught plus iy naught. That means mod of z naught is equal to square root of x naught square plus y naught square. And the condition given to us is 2 into z naught square equal to r square plus 2. So can I write that condition as 2 into x square plus y square equal to r square plus 2. Now we can solve this problem in two ways. We are going to do it in one way in which we are not going to use most of the complex numbers concept. We are going to take this as whatever is given to us as a circle with radius. We'll try to do linear equations and look for two conditions, two equations we have. You can see that this distance is nothing but equal to r, and we also know that this distance is equal to 2r. So we can have two equations there, and we have another condition coming from here. So we should be able to find out what is mod of alpha. What is mod of alpha, by the way? We'll do that. Mod of alpha is nothing but a plus ib. So it's nothing but equal to square root of a square plus b square. We have to find out what is the value of square root of a square plus b square in this particular scenario, where the alpha and 1 by alpha conjugate are points on two circles with center as x dot comma y dot and with radius as r comma 2r. So a comma b is a point on the first circle, and a by a square plus b square comma b by a square plus b square is a point on the second circle. So if you can see there, we have three conditions. First condition, distance between 2 points equal to this radius. Second condition, distance between these 2 points is equal to another radius whatever we have there, and the third condition is this. So with these equations we should be able to find out root of a square plus b square. This is one method. The another method is converting whatever is given as x minus x naught whole square plus y minus y naught whole square as nothing but equal to z minus z0 mod of that square is equal to r square. That is nothing but converting this equation again back into complex number. That approach we are not doing. That approach is a little bit easy approach, but we need to understand couple of complex number properties. So in this session we are going to do it in just our plain way without using any most of the complex number concept. Okay, so what are the three conditions I said? One is from x naught y naught to a comma b, what is the distance? Second thing is a by a square plus b square comma b by a square plus b square, and the distance from center to that is 2r. So these are two conditions, and this is the third condition. So let's go ahead now and write down our conditions one by one. The first condition will be a minus x naught whole square plus b minus y naught whole square b minus y naught whole square is equal to r square. This is our first condition. What is the second condition? Second condition will be a by a square plus b square minus x naught whole square plus b by a square plus b square minus y naught whole square is equal to 4r square. This is the other condition we have. Anyway, we have this condition which will be leveraging, that is nothing but equal to 2 into x square plus y square equal to r square plus 2. That we will be leveraging. So first we will try to understand these two equations and see how we can compare these two equations. Okay, for that what we will do, we'll expand this and we will see what happens now. My next step will be working on the first one. I have a square plus b square plus x naught square plus y naught square. If you observe, I am separating a square plus b square and x naught square plus y naught square because we have a condition value for x naught square plus y naught square, that is x naught square plus y naught square. So we have that, so we can leverage that. That's why we are just putting them separately. What else we will have? A square b square minus 2ab, right? So can I say minus 2a x naught minus 2b y naught is equal to r square. This is coming from the first equation. Let's go to the second condition. What second condition will give me? Second condition will give me a square by a square plus b square whole square plus b square by a square plus b square whole square plus x naught square plus y naught square minus 2a x naught by a square plus b square. We are not doing nothing great, we are just expanding the formula using a minus b whole square minus 2b y naught divided by a square plus b square is equal to 4r square. Now we know about a square plus b square, that is what we have to find out, so we need it. We know that x naught square plus y naught square can be converted into r square, so we have to attack on this part 2a x naught 2b y naught. For that we don't have much information and it is available in both the equations, so our focus will be to eliminate this particular condition from both of them, so that we can equate that. Then we should be having a condition in which we will have only a square plus b square and r square, because I can write x naught square plus y naught square in terms of r, and if r cancel on both sides I should be able to get my value of what is a square plus b square. So what we will do, we will take the first condition as it is, we will write down here this is our equation number 1 and this is our equation number 2. Now we will work on number 2. What we will do is we will take number 2 and multiply that with a square plus b square. So when I do that, I can get minus 2x ax naught minus 2b y naught, which will be nothing but equal in both of them. Then I can subtract. I should be able to eliminate this 2ax naught and 2b y naught terms. So let me multiply that. So for that I will say I will take 2 and multiply with a square plus b square. So let us see what happens now. When I do that, the next step will be a square plus b square by a square plus b square whole square. That's nothing but equal to, if you simplify it's just 1. How it is? The denominators are same, you can add the numerators, that is a square plus b square by a square plus b square whole square, that is 1 by a square plus b square. Exactly, you are multiplying with a square plus b square, so it becomes 1, and you are multiplying here, it is a square plus b square into x naught square plus y naught square minus whatever we want, that is minus 2a x naught minus 2b y naught is equal to 4r square into a square plus b square. Now what we will do, we will try to get 2a x naught 2b y naught, right? That is what is our what we want to eliminate. So what we will do for this, we will go to the first equation and keep that 2a x naught 2b y naught to that side, and we will equate them. We will have a square plus b square plus x naught square plus y naught square minus r square is nothing but equal to 2a x naught plus 2b y naught. That is what we want to eliminate from both the conditions. Now when I go to the second condition, I will have 1 plus a square plus b square multiply with x naught square plus y naught square minus 4r square into a square plus b square is equal to 2a x naught plus 2b y naught. Now you can see that both of them are equal to 2a x naught plus 2b y naught. That means I can equate these two conditions. So we are approaching our solution almost. So now can I equate this and I can write down, this is my equation which is very important now, which we are going to use to solve this. We just convert x naught square plus y naught square into whatever we have that condition in terms of r, like r square by 2 plus 1. We should be able to solve the problem easily within 2-3 steps. Okay, now we will leave this as it is on the first side, x naught square plus y naught square minus r square is equal to 1 a square plus b square, multiply that with x naught square plus y naught square minus 4r square into a square plus b square. We are halfway through, so we have to just simplify this now. We have to put only one formula, that is x naught square plus y naught square equal to r square by 2 plus 1, and we simplify that, we should be able to get it. So let's go to the next step. Now let's substitute this formula, that x naught square plus y naught square, x naught square plus y naught square is equal to r square by 2 plus 1. So that formula we want to leverage, and we want to simplify this now. So let's go ahead now and write down that a square plus b square, a square plus b square plus, what is x naught square plus y naught square is r square by 2 plus 1. So I'll write down that r square by 2 plus 1 minus r square is equal to 1 plus a square plus b square multiply with r square by 2 plus 1 minus 4r square into a square plus b square. Now remember, we have to find out the value of square root of a square plus b square. So we need to first find out what is a square plus b square. Now this is pretty simple linear equation. It's like basically equation in two variables. May not be linear, but equation in two variables, we should be able to easily simplify that. So what we will do, we'll just expand this now. Next step, in 2-3 steps we are going to finish it. So the next step will be, what we will do, we'll multiply this, we'll just simplify this. On the left hand side I'll have a square plus b square, which I want, and plus r square by 2 plus 1 minus r square is equal to 1 plus, we'll expand this, a square plus b square plus a square plus b square into r square by 2 minus 4r square into a square plus b square. Now what we will do first, we'll try to see what we can eliminate here. Now I can cancel 1 and 1, I can do that. Then I can cancel a square plus b square, a square plus b square, and then what else left out, we have all r square common. So why can't I go ahead and eliminate that r square from all of them? So this r square and this r square, all of them will go away. Then what is left out, my last step will be, here it will be 1 by 2, here it will be minus 1 is equal to, I have a square plus b square, I can take common, and I have 1 by 2 minus 4. So if you simplify that, that's equal to minus 1 by 2 equal to a square plus b square into minus 7 by 2. Now 2 will cancel, 2 will cancel, we have minus minus cancelling, left out is a square plus b square equal to 1 by 7. A square plus b square equal to 1 by 7, that means square root of a square plus b square is equal to 1 by root 7. So our option where we have 1 by root 7 is the correct one for this particular problem. So the solution is C. Let's summarize this before we wrap it up. We have been given that two complex numbers alpha and alpha, which we have taken as a plus ib, and alpha conjugate, which is nothing but a minus ib, 1 by alpha conjugate, that is a plus ib by square, a square plus b square. These two complex numbers lie on the circles x minus x naught plus whole two circles which are with center is x naught comma y naught and with radius r comma 2r respectively. So we have three equations now. First equation comes from taking the alpha lying on the first circle. Second comes from 1 by alpha conjugate lying on the second circle. And third is a given condition which says that z0 is nothing but x0 plus iy0, and 2 z0 mod z0 square equal to r square plus 2. Now we can solve this problem in two ways. One, by converting the given circle equations into complex numbers and try to solve them, which will be, I think, a little bit easier way. But if you are like me, you don't understand, basically, like sometimes you don't get what the properties are doing, you want to do it in your traditional way of doing it, then you are welcome to do that. You can directly take these two equations and you can see like what you can eliminate from both of them, and supplying the third condition whatever we have, we will be able to solve it and find out that a square plus b square is nothing but equal to 1 by root 7. So that's an interesting problem which I thought of sharing with you. Please go through that and let me know your feedback. Do you see that this solution makes a little bit sense or not when compared to the other standard solution you have, where you convert that as z minus z dot mod whole square equal to r square and z minus z dot mod whole square equal to 4r square. Then you put alpha and 1 by alpha dash in that, and you apply the property that alpha into conjugate of alpha is nothing but mod of alpha whole square, like what we do. That's another approach. We will be doing that in the next session. So in this session we try to solve it without using much of complex numbers. By taking them as points in the Argand plane, we were able to convert the complex numbers into the, I mean, like from into geometric, we got the points as a comma b, a by a square plus b square comma b by a square plus b square. Two equations, distance between 2 points, from distance between circle to any point on the circle is radius. Two equations, another condition which is given, we were able to find out it. So just let me know your feedback on this. Thanks for your time and support. I'll catch you once again. Till then, keep smiling and sharing. Bye for now.